The next topic is backpropagation algorithm. So let us see what is backpropagation. So backpropagation is a supervised learning algorithm for training neural networks. So in the previous three videos, I've already discussed about the neural networks. It is the fourth part of the artificial neural network. So let us see why we need backpropagation. So we need to design a neural network. So we need to initialize the weights with random value. That is, we have to initialize random weights. There is a least probability that whatever the weights we have randomly defined or assigned will lead to a correct output. So if the error is 0, that is, if the predicted output and the actual output is same, then the error is 0. So no need to modify the weights, whatever the random value we have chosen. Suppose if the error is high, we need to change the parameters. That is, we need to change the weights so that the error is minimum. So what we do is we backpropagate. We backpropagate and update the weights. That is, first we update W5, W6, then we update W2, W3 and then W1, W4. Like this, we backpropagate and go on updating. In the next iteration, that is forward pass. So we use these weights and calculate the predicted output. If the predicted output and the actual output we compare, if the error is again high, again we go on updating the weights backward. So again, after updating the weights in the forward pass, so we predict the output. This continues until the error is minimum. So this is known as backpropagation. So let's just see an example here. So this is an example neural network. These are the x1 and x2 values and these are the weights and this is the target of the two targets, target 1 and the target 2, target 1 and the target 2. So here I have already explained about why we need backpropagation, that is a forward pass and the backward pass. So now let us solve the problem and then understand. A complete pass over all the patterns in the training set is called as an epoch. Okay. So here let us take an example here. So here this is the input layer, this is the hidden layer and this is the output layer. So here net H1 we have to calculate. This is the net H1, this is the net H2. So net H1, what is the input for the net H1? It is x1 w1 plus w3 x2 and it is also having an input bias input. We already discussed about the neural network in the previous video. So all these terms you will be knowing. So once again I will be not explaining the video. You can refer the previous videos. So w1 x1 plus w3 x2 plus b1 into 1. So here substitute the values for this net H1. So what is W1? W1 is 0.15, X1 is 0.05, then W3 is 0.2 into X2 is what? 0.10 and bias is 0.35 and input for this bias is how much? 1. Okay. Substitute and you will get the value. And another point you note, if you remember in the previous video I have explained, every perceptron or every neuron, so it is having summation function and an activation function. So now we have calculated the summation function, that is net H1, summing all the inputs with its weights. So next you have to apply the activation function. So different activation function. Now we have applied the activation function as 1 divided by 1 plus e to the power of minus x. So this activation function I have written it as out H1. Out H1 is equal to 1 divided by 1 plus e to the power of minus H1. Here x is nothing but here H1. So is equal to 1 divided by 1 plus e to the power of, for net H1 how much we got the output? 0.375. 0.377375. Substitute here you will get 0.5. Similarly what you have to do is you have to calculate the net H2 and also you have to calculate out H2. So here like here net H2 and You have to calculate out H2. So I've already calculated out H2. So I've already written here output. So next, calculating Y1. So calculating Y1 means this one. Okay. So for Y1, what is the input? H1 output and H2 output. Okay. So Y1 is nothing but Y1 is equal to, this is what we have written, out H1. This is out H1 into W5, out H2 into W6. Okay. And the bias. So write it down is. Substitute the values. What is out H1? This one. What is into W5? What is the weight? Use FR. Plus out H2, this one. What is the W6? Refer it, substitute here. Plus bias. So you are getting the Y1 value. Similarly, you have to calculate Y2 value. Okay. Similarly, you have to calculate the Y2 value. Now, calculate the total error. Okay. Calculate the total error. So total error is nothing but this one. Okay. So Y1 and Y2. What is the total error? What we have got. Okay. So one more thing. So here this perceptron what we are having for Y1, it is having what? Summation and as well as activation function. So what we have done here, we have done for Y1 the summation. Okay. This we got. Activation function, you have to again apply the activation function. This is the final output of this perceptron. What we have got. Final output of this perceptron is 0.75. In the same way, you have to calculate out Y2. That is Y2. Calculate the summation. Calculate the activation function. Okay. In the same way, you have to calculate. Calculate the total error from Y1 and Y2. So average error we have taken. Okay, total error. So prediction minus actual. So what is the prediction? Out Y1 we got. What is the actual? That is target 1. Target 1 means 0.01. Target 2 is 0.99. So for Y1 with respect to T1 and Y2 with respect to T2. What is the total error you calculate? Okay. We have to take the average error. So how much we got? 0.298 total error. Okay. So the error is high. So what we have to do is, what I told here in case of backpropagation, if the error is more, okay, we have to backpropagate, backward pass we call. Go on updating the weights, all the weights you go on updating. Then after updating the weights, forward pass. Again calculate the output, predicted output. Compare with the actual output. If the error is less, equal to 0, no need to update the weights. You have achieved the target. Otherwise, update the weights, that is backward pass. So now, since the error is more, so there is an error. So what we have to do is we have to reduce error. So what we have to do is we have to backpropagate and update the weights. So here in this video, I'll show only updating one parameter, that is W5. Okay, not all. Okay, I'll show only one. Consider W5. So now I have to update the W5 weight. Okay. Now we have to update the weight W5. This I have to update the weight W5. So if I want to update the weight W5, okay, this is W5. Here W5. Where it occurs, check it out. W5. It is having with respect to this what? Y1. It is attached with what? Respect to Y1 and H1. Yes or no? Y1. So now, so error at W5, it happens because here there is a change in total error with respect to what? Change in W5. So there is a change in error with respect to what? Change in W5. So here the error at W5 is because of there is a change in total error. If there is a change in total error, then that is with respect to what? A change in W5. So change of total error with respect to change with W5 is equal to change of total error. So here E total with respect to EW5 is nothing but it depends upon what you can see. So that is change of total error. I can write it as it is depend upon with this W5. Okay, this total error is depend upon this W5 weight. So I have to change this W5. Change in W5 with respect to it is also depend upon change with output Y1. Okay, change of output Y1 is depend upon change with Y1 into change of Y1 is depend upon change with W5. So how it depends, you can see change of total error with respect to out Y1 with respect to out Y1 with respect to W5. Change of total error with respect to out Y1 with respect to what? Change in Y1, change in Y1 with respect to what? Change in W5. So that values we have to calculate. Okay, now we will calculate one by one this value and this value. Okay, change of total error with respect to change of out Y1, this one. So change of total error, what is the formula? Take down that formula. What is the formula? This is a formula, no? Take this formula, write it down. Okay, differentiate with respect to what? Out Y1, you will get this one. Okay, apply the differentiation mathematics. So now what you have got? T1 value substitute out, final value of differentiation of this equation, you will get this one. T1 value substitute, out Y1 value substitute, you will get this value. Similarly calculate this one. So now substitute what is out Y1. Out Y1 we already know that. Out Y1 is, this is the equation. If you differentiate this equation with respect to Y1, we will get this one. Okay, substitute the value of out Y1. What is the value of out Y1? Substitute. Okay, substitute of out Y1 value and you will get this answer. So out Y1 value, see previous, how much you got? 0.75. That only you substitute here, you will get 0.18. Similarly this equation next you take. What is the value of Y1? Change of Y1 you take. So what is Y1 equation? This is the equation. That's the equation you take. Okay, that equation I've already taken here. Differentiate with respect to W5. Differentiate with respect to W5. You'll get this equation after differentiation. Okay, this is the final value you'll get after differentiation. You'll get out H1 you'll get. Substitute the value of out H1. What is the value of out H1? See, out H1 value is how much? 0.59. Substitute at 0.59. Okay, you got. Now change of total error with respect to change in W5. Substitute here. Substitute the value of this and this. Substituted, multiply, you will get here. You are getting 0.08216. Now your next step is you have to update now W5. Okay, now for updating the W5, this is the equation. W5 is equal to W5 minus learning rate into change of total error with respect to change of W5. I have to change the error, no? Total error. By changing with what? W5. So it is a change the total error with respect to change of W5. So I have to change W5. So I am changing here W5. W5 is equal to, okay, what is the previous weight of W5? Check it out. What is the previous weight of W5? 0.4. Substitute here 0.4. My learning rate I have taken as 0.5 into what is the output of value of this? Take down, substitute. You will get W5 as 0.35. Now new W5 weight is 0.35. Similarly, update for all the weights. Okay, update the weights. I have already done. Update for all the weights. Okay, apply the forward pass. Again break the output. This will be continued. So algorithm for this is you have to initialize the random weights. Okay, next predict the output. If the output is error is minimum, okay. If the error is high, you need to change the weights. Okay, after changing the calculating the weights, you have to update the weight by using this formula. Just now we have seen it. Again forward pass, again calculate the difference, again If the output is predicted output and the actual output difference is more, again backward pass. Okay, update the weights. So this will continue, backward pass. Okay, go backward pass, update the weights, again apply forward pass, again print the output until the error is minimum. Okay, so this finishes the backpropagation topic. Thank you.